Um, so first question, remember when we have a sign of a sum of two things, and one of them is an actual angle. When you use the addition or the double angle or whatever you can use there, you will be able to find one of them as a number. Yeah. So first thing, we have sine of this thing equal to 3 cos of the same thing. And then we have to show that tan of 2 theta is 1/2. That doesn't even look connected. Yeah. We need tan, we have sine, we have cos, so we can probably start dividing and have at least tan, and then we will see what we do with the tan. Yeah. And sorry, because I know when you say that you have the answers here, it was just my working out. I didn't clean it. So I would just divide sine divided by cos, so we will have on the left that tan of brackets 2 theta plus 1/4 pi equals to 3. That's what we have. Yeah. Now we need tan to theta. That means we can use, you didn't finish the last one. Okay. Yeah, so time issues. Tan of A plus B is in the formula booklet. We call A equals to B, and then we have tan to A. And then tan to A is what? I never remember that one because we use more the other ones, no? Is 2 tan. So this one is what you have, yeah? A plus B. Then you call A and B the same, and then we have 2 tan 1 minus tan squared. So 2 tan 1 minus tan squared. So let's see if with this we can do something. So we have 2 tan of, no, I don't need this one. I need precisely the other one, no? Tan of one, tan the other. So it's, sorry, apologies. So it's tan 2 theta plus tan pi quarters divided by 1 minus tan 2 theta tan pi quarters. Yeah, tan pi quarters is a number. We can use the calculator, is 1. Yeah, and this is equal to 3. So this is 1, this is 1, and then we have an expression that is tan 2 theta plus 1 over 1 minus tan 2 theta. From here, we just need to make tan 2 theta the subject. Yeah, so I just multiply on the right, so I have tan 2 theta plus 1 equals to 3 minus 3 tan 2 theta. We put things together, and on the left, I'm going to have 4 tan 2 theta equals to 2. So tan 2 theta is going to be 2/4 or 1/2. Yeah, it comes from here. So when you have an angle and it's an angle plus a number, if you use the addition formula or the compound formula, you are going to get numbers there. Yeah, so that's what you are chasing with this. Yeah, is this okay? So this is the first part. Now, hence, so using this, find in short form the exact value of tan theta. So again, we go from tan to theta to tan theta. So we are going to use now the double angle formula. So we have, we know that tan to theta is 2 tan theta 1 minus tan squared theta. That's the formula. And we need tan theta, and we know that tan to theta is 1/2. So instead of tan to theta, I'm going to have all that equals to 1/2. And again, it's just making tan theta the subject. They say theta is an obtuse angle because this is a quadratic equation in tan, so I will get 2 answers. I will have to think which one it is. Yeah. So we again rearrange that. We have tan 2 tan theta is 1/2 minus 1/2 tan squared. I'm going to rearrange and multiply everything by 2. So I have tan squared theta plus 4 tan theta minus 1 equals to 0. And we factorize. And I'm going to do it just with the calculator. So we have, let me get who is coming in. So I'm just going to solve that one. So it's 1, 4, and minus 1. Hello, Mihail. So I get tan theta equals to minus 2 plus minus root 5. I have two answers. They say the angle is obtuse. And for this one, the best thing that you can use is just the Gauss theorem. Yeah. Angle obtuse is in this quadrant. Only sign is positive, which means your tan must be negative. So you are going to choose the negative one. So minus 2 minus root 5. And that's your answer. Yeah. When they say give the exact value of sine, cos, or tan, and they tell you the angle is obtuse or is acute or whatever, is to choose one of your two answers. Usually you get roots and then you get two answers and you have to choose using that information. Is this okay? So if we're just playing with the addition angle for the addition angle for the tan in this case, and remember you have them in the formula booklet. So it's important that you remember what you have, more or less. You have the A plus B, and then you can do A plus A. That would be the double angle. Okay? Any question? No. Next, then you have a series, sequences and series. So they say the sum to infinity of a geometric series is 96. I think this one, you find it okay, no? Nobody complain about this one. So that's the sum to infinity. First term of the series is less than 30. So we know that is less than 30. And we know the second term is 18. I'm going to call it U because they call it U, but it doesn't matter, yeah? So, well, yeah, A, and this is the second term is 18. So this is what I know about this series. Find the first term and the common ratio of the series. I'm going to use these two. Yeah, sum to infinity, we have the formula in the formula booklet is A, 1 minus R, and we know this is 96. And then the second term, U2, is, remember, U1 multiplied by R. So that means the second term, 18, is the first term, that is A multiplied by R. So one equation, another equation, I'm going to solve simultaneous equations, and from there I'm going to get A and R. Yeah. If you want, you can make A the subject, put them together, and that's it. So for example, we have that A on the first one is 96 minus 96R, and on the second one, A is 18 over R. We make them equal to each other, so 96, and we are going to have a quadratic equation. So we multiply everything by R. Yeah, we can reorganize a bit, and we have, well, can we divide 96 by 18? No. But we can divide by what? What can we divide by? Not by 9, by 6? By 6, okay, yeah. So we have 16R squared minus 16R plus 3 equal to 0. We get two roots for that. One is going to be smaller than 30, one is greater than 30. Not for this one. Oh, it's better to find first A, probably. Yeah. Okay, we get the two values of R. So let me get the two values of R. Probably would be better to find A first because we have something for A. 16 minus 16 and 3. I get 3/4 and 1/4. So 3/4 and 1/4, both of them would work because both of them are smaller than 1. So that will allow me to find S to infinity. So I cannot really choose. But then when I find A and I substitute this one and this one, I have to be sure that A is smaller than 30. Yeah. So if I get this one, so when R is 3/4, I get 24, which is the right one. Yeah. So R is going to be 3/4, and then A is going to be 24. Yeah, does it make sense? So you have two values of R and two values of A because it's a quadratic, but we have a way to choose because they say A must be smaller than 30. Yeah. If you, instead of finding R first, you find A, then you don't have to check which are. You just choose the smaller than 30 and then you go ahead with that. Is this okay? This formula is in the formula booklet. This is not. Now, so show that the nth term of the series can be written this way. So the nth term of a geometric series is not in the formula booklet, but we know is u. So the first term multiplied by r to the power of n minus 1. And remember, this one is very easy to deduce if we need to. Un is A is 24, and R was 3/4, no? 3/4. 3/4 to the power of n minus 1. And we need to show that this can be written as 3 to the power of n over 2 to n minus 5. 2 to n minus 5. So it's just going to work with these numbers until we have this expression. Yeah? Did any of you struggle? So 24, we can write it as, and we have a 2 here. Yeah? So we are going to write this as in 2s and this one in 2s and 3s. So 24 is what? 3 times 8, no? So 3 times 2 to the power of 3. We have that. Then in the numerator, we have 3 to the power of n minus 1. And in the denominator, we have 2 to the power of 2 to the power of n minus 1. Yeah, so I want to write that way. So 2 to the power of 2n minus 2. Yeah, so I have 2 to the power of 2, that is the 4 to the power of n minus 1 multiplied exponents. Yeah, when I put all these together, in my numerator, I have 3 and 3n minus 1. When I add the powers, I have 3 to the power of n only. Yeah, I am adding m minus 1 plus 1. And in my denominator, I have 2 to the power of 2n minus 2. And this one can go down subtracting. So the same that this one can go up subtracting, this one can go down subtracting. We are doing the reciprocal. So we have 2n minus 2 minus 3 is 2 to the power of 2n minus 5. Yeah, so a number can go down the denominator just with negative powers, the same that it can go up. Yes, everyone? Then next one, and that was for marks, and it wasn't too bad. So hence, show that this happens. So logarithm to the base 3 of un is this expression here, which means they have taken lengths here, logs here. So let's going to do that to the base 3. So let's take logs to the base 3 there. And we have log un is log 3n to 2n minus 5. And we can see how they have separate things. Yeah, so they have then factorized the n. So let's do the same. So we have log un. We separate this using the properties of the logs. So log 3n minus log 3 to 2n minus 5. So log un is n. So 3 and 3 cancel, remember? And then this one can go to the front multiplying. So I have minus brackets 2n minus 5 multiplying log 3. 2, and they have factorized the n. Yeah, so for that, I'm going to expand that bracket and then factorize the n. Minus 2n log plus 5 log 3, 2, and then we factorize the n. Yeah, n brackets 1 minus 2 log 3, 2 plus 5 log 3, 2. Remember, log of a number, when I have that, is a number. So I work with it like if it was 7 or 13. Yeah, the same way. I expand brackets in the same way, I factorize in the same way, and all that. Is this okay, everyone? Yeah? Any question? No? So that one, this question is it. Yeah, so please remember the formula booklet. What things do you have there? More or less where they are. Yeah, so you don't panic in the exam thinking that you don't know the formula. Now, we have a parametric question mixed with some logarithms there, some expressions there. Yeah. So this one, we have done one very similar, I think. So we have x is quadratic, and then y is 6 ln of t plus 3. Yeah, and we have to find the Cartesian equation and write it y equals something. So this one is a bit particular, so I would recommend you, when this is the case, check, because this is common. If you have an exponential or a logarithm and then a quadratic, many times what they do is wherever is inside the log or the quadratic or the exponential is part of this quadratic. So if you complete the square here, look what we have. If we complete the square, we have t plus 3 squared, then minus 9 minus 16 is minus 25. Yeah, they do that on purpose. So check, yeah, if you have log and a quadratic or exponential and a quadratic, what is here in the bracket might be part of the quadratic. And that makes your life much easier, yeah, because now we can say, we can make t plus 3 the subject here, t plus 3 the subject here, and make them equal to each other, or substitute one into the other, whatever you prefer. Yeah. So we have y over 6. I'm going to make the subject because it's easier than to work with it. Yeah. So we take exponentials. So y e to the 6, x is t plus 3. And then I can substitute that in the other one. So, well, I need y the subject, no? I don't know what is better. Well, we have x is going to be e to the power of y over 6 squared minus 25. Yeah, I'm substituting there, I suppose, a few ways of solving them. Yeah. So I have that x is e to the power, remember, multiply the indices and just power of a power. So y divided by 3 minus 25. And now I need to rescue that exponent. How am I going to do that? I'm going to take lengths, but I'm going to bring all the numbers to the other side. Yeah. So I'm going to have x plus 25 is e to the y over 3. And now I can take lengths. So y over 3 is length of x plus 25, which means that y is 3 ln of x plus 25. And maybe there is a shorter way of doing this, yeah? So I not tell you 100% this is the best way, because I don't think so. Yes, but we are just trying, please remember, when you have learned or exponential and a quadratic, usually if you've not factorized the quadratic, if you complete the square, you go faster. Yeah, and so that means A is 3 and B is 25. Yeah, did you get this one? Yeah, okay, excellent. If not, if they give you all the numbers here, you could substitute, but this is not the case. They give you the constants and you need to find them. So it's not one of those questions that you can substitute and then just check that that's the Cartesian. You have to work it out. Now, curve C cuts the y-axis at point C. So this graph here cuts the y-axis at point C. So that the equation of the tangent to C at P can be written in this form. What are we going to do? Because I'm talking all the time. I know you have been doing the questions, but what are we going to do? Who can tell me? Chica, what would you do?
If it cuts the y-axis at point P, it must mean x equals 0. And so we put t squared plus 6t minus 60 in equals 0, and then we solve to find 9t. But it has to be one value of t, because like t is greater than minus 3. So I think we have to reject one of them.
One of them, you have here what the parameter can be. Yeah, so that's a clue. So they say the curve C cuts the y-axis at point P. So we have our graph doing something like this and cutting here at point P. And then show that the equation of the tangent to C at P can be written in this form. The equation of the tangent. So the equation of the tangent is going to use the gradient here. Yeah. The gradient here is going to be the derivative. We know how to derivate that function. And then we'll see what we can do. So derivative of that function. So for B, derivative of this function, derivative of learn, remember, is the function in the numerator, so the derivative in the numerator, the function in the denominator, and I have a 3 here multiplying, so I'm going to have 3 over x plus 25. X, 3 over x plus 25. My derivative at that point, because I know this point, the x is 0, is going to give me the gradient. So the gradient of the tangent is going to be 3 over 25. I know the gradient, but I need the point. And I know the x is 0, but I need the y. As Aratika was saying, I'm going to make the x equal to 0, and then I'm going to decide, I will find the y with that. Yeah, so we are going to make this equal to 0, find the parameter, discard one of them, so t squared, and trying to find p, yeah? So plus 6t minus 16 equal to 0 gives me what? T plus 8, t minus 2. Yeah, t plus 8, t minus 2 equal to 0. So t is minus 8, t is 2. And look, always for the restriction, so t must be greater than minus 1, so minus 3, so this one is not my answer. So t must be 2. When t is 2, the y is going to be 6 ln of 5. Yeah, just substituting the t by 2, y is 6 ln 5. So I have my point. My point is 0, 6 ln 5. And I have my gradient, which is 3/25. Yeah, remember that the points in a parametric curve is just substituting the values of the parameter. And we have to find the equation of the tangent and just leave the x and the y on one side and everything else in the other side. So equation of the tangent, y minus 6 ln 5 equals to the gradient, x minus 0. Yeah, I'm just going to write x. We multiply everything by 25, so 25y minus 3x, and then 25 times 6 is what? 150, no? 150 ln 5. Yeah, is that your equation? Yeah. And they are integers. Always check for that, because if not, you potentially could leave the fraction. Yeah, but you don't want to. Is this okay? Yeah, any question with this? No? Then next, this one of you asked me, well, but he's not here, but I think it's a really good question because it's a serious combination of things. We have a medical researcher is studying the number of hours T a patient stays in hospital following a particular operation. Histogram here summarize the results of for a random sample of 90 patients. So this is the histogram for 90 patients. Yeah. Use the histogram to estimate the probability of T between 10 and 30. Who checked if the scale factor is 1? Did you remember to check that? Can you show me, send it to me in the chat or show me thumbs or something? Did you remember to check if the scale factor is 1? You remember? You know what I mean by the scale factor? Not always, exactly. So not always in the year 13, year 12 questions in A levels, your area is going to be equal to the frequency. Remember, the area is going to be proportional to the frequency, or the frequency proportional to the area. It doesn't matter how you write it. Yeah, doesn't matter because the k is just going to be the reciprocal. But you have to check because it might not, and then all the rest of the question is going to be wrong. So what we are going to do is to find area, add them together and check if we get 90. Because instead of 90, we could get, I don't know, 180. So then you have to double all the areas. If you check that, if you find the areas of all the bars And it's because we have a scale here, we are not counting in squares. Remember, if we don't have numbers, we don't have a scale, we will be counting in squares. We have a scale, we are not. We are finding areas. And thank goodness, because it's not easy to count the squares here, yeah? They are like half squares and it's not easy. So we are finding areas. So you have to be clear what is, so we have 5 here. So every unit is 2 bars, yeah? So 2 little squares. So sometimes it's not easy, but we have 1, 2, 3, 4 times 2.5, no? So what do we have? 10. And we will do that with all the bars. And in this case, they add up to 90. So frequency is equal to the area. You don't have necessarily to show that you are checking that, which means if you don't check because you forget, and the k is 1, like in this question, you can get away with that, with not checking, and everything will be correct, yeah? But if k is not 1, then all your answers will be wrong. So it's very risky not doing it, yeah? Then, so we know that the area is the frequency. So now they say probability. They are asking me a probability. That t is between 10 and 30. So what we are going to count is between 10 and 30, how many we have, and then divide by 90 because it's a probability, yeah, out of 90. So we count area between 10 and 30. So we need this part of the bar and up to here, yeah? So how many we have here? So have 2 and then times, what is this one? 4. So this is 4.2, no? So times this bit here is 2 is the width, and then 4.2 the height. This one is 1, 2, 3, 4 times 4, no? So this one is 16. This one is 1, 2, 3, 4 again times 3.5, 3.5, no? 3.5 and then times 4. And this one we have 10 times 1, which is 10. So we add all of those, and those are the patients. No, we are counting patients, hours, patients. Yeah, patients that we have there. Yeah. So we have 48.4. I don't get the whole number. Have I done something wrong? 48. Do you get 48.4 out of 90? So the probability is 0. So this probability here, probability is 48.4 out of 90, which is 0.53777. So I'm just going to write 8. Yeah, let me check. Yeah, okay. Okay, is this okay, everyone? So now that we have the histogram, it's just reading it. Now, for these 90 patients, the time spent in hospital had a mean of 14.9, standard deviation on 9.3, and we are, Thomas is suggesting to model this by a normal distribution. Yeah, mean standard deviation. With reference to the histogram, state giving a reason whether or not Thomas' model could be suitable. Who can tell me something about this? What do you think? Look at the histogram and tell me if the normal distribution is a good model. Fraser.
Like it's not symmetrical and the bell curve is symmetrical, so no.
Exactly. To be able to model this with a normal distribution, the bars should be more symmetrical. No, not perfectly symmetrical, not continuous. It doesn't matter because we are modeling that thing with a normal distribution. So the continuity is not a problem, but the symmetry is. Yeah, so this thing is skewed. So no, it's not a good idea. Yeah, don't worry about the continuous or discrete, because for modeling that is not a problem. Now, Xiang suggests that the frequency polygon based on this histogram could be modeled by a curve with this equation. Frequency polygon, you remember what that is? Frequency polygon is just a polygon that joins, remember, the midpoint of the tops of the bars, straight lines. Yeah, so it's a straight line, straight line, straight line, straight line, straight line. Yeah, that's the frequency polygon. And they are asking me, or they are saying that we are going to model that with this function that we are not very sure how it looks like, because it's an exponential and then multiplied by x. So we are not very sure, but it doesn't matter. Between 0 and 4. And it says x is measured in tens of hours and is highlighted. Yeah, so that be careful, because it's for a reason. Between 0 and 4. So that means here, instead of having between 0 and 40, we are going to work between 0 and 4. Now, use algebraic integration to show that this happens. Where do you think this comes from? So what is the connection? Because this is not a unique question. We have done something similar, not with normal distribution, but a histogram, and they were trying to or model the histogram or model the frequency polygon. What is happening here? Who can tell me? What I'm going to make equal to what to have this expression? Does any of you remember? We have done another similar question. Daniel, what?
It's like you're finding the area, I think.
And that's
Just
going to be equal to what?
Equal to like 90.
Equal to 90, exactly. The area under my frequency polygon must be my frequency. So we are trying to model this area, which is 90, by the area under the frequency polygon, which is going to be 90. Yeah. And because we have a function, the way of finding the area under that function is integrating. And that's where this integral comes from. Yeah. So the area between 0 and 4 under this graph must be the total frequency. We have to have 90 patients there. Does it make sense? Please remember this, because this is an example of normal distribution, but there are other examples like we have done. So we are going to integrate between 0 and 4, kx, x minus 1. So between 0 and 4, kx e to the minus x dx, and we are going to make that equal to 90. Yeah. No, before that, before making that equal to 90, we are just going to integrate. And sorry, I'm skipping ahead. So for now, we only have to integrate between 0 and n this function and see that that's the expression. Yeah. So forget what I say. Between 0 and n, that expression, and then we will use the 40 and the equal to 90. So we are integrating that. What method I'm going to use to integrate this? I have a product. I'm going to integrate 5 parts. Yeah. So yeah, Amelia, can you help me, please?
Yeah, so you'd use the late acronym. So then the U would be the KX. And then the DV would be the E to the minus X.
Exactly.
And then you would do the differentiation. So it's just K. And then you would integrate that one, which is minus E to the minus X.
Exactly. Minus E to the minus X. And then we substitute in the formula is UV. So I have minus kx e to the minus x, so uv, and then minus the integral of v du. V has a minus at the front, so I'm going to change that. And then I have k again e to the minus x dx. That this one, I don't need parts or anything. Yeah, k is a number. We don't know it, but it's a number. And I'm going to substitute the limits at the end for both of them. Yeah. So this one becomes minus k x e to the minus x, and then plus or minus. When I integrate this one, I have the k and a minus because of that minus in the new exponent. So e to the minus x between 0 and n. That's what I have. What I have, yeah? Substitute the n. I have minus k n e to the minus n minus k e to the minus n. And then I substitute the 0. This, because has an x at the front, is 0. And this one, e to the 0 is 1, and then is minus k. Yeah, so I have minus k. Yeah. And how do we have to get the answer? We don't have the k anywhere. Sorry, we don't have the k. So I'm going to just clean it. We're integrating just. I just wanted to go and do the last bit. Sorry, we don't have the k. Yeah, so this is one. It's just even simpler. Yeah, so no k, no k, no k, no k, and no k. So this is minus 1. Minus 1, yeah. And we have 1 minus, and then we factorize the e to the power of n. So if we factorize, we have minus e to the minus n multiplied by n plus 1. Yeah, so I factorize here and here the e to the minus n, or the minus e to the minus n, and then we have plus 1. Yeah, if we write in the other order, this is what we have. Yeah, and that's where it comes from. So they are kind of scaffolding the question for you to get ready for the last part. Now, show that for Xiang's model, k is 99 to the nearest integer. We say that the area under the function, which is not this integral, but almost, so the area is going to be k. The area under the graph is going to be the integral between 0 and 4 of kx e to the minus x, and this is going to be equal to 90. And what we know is the integral between 0 and n without k, so x e to the minus x dx. Yeah, that's the one that we just integrate. So how do I rewrite this? This thing here is going to be k, and then I'm going to use the expression here with n equals to 4. Yeah, because I'm integrating instead of between 1 and n, between 1 and 4. Sorry, so I'm going to substitute, and I have k brackets 1 minus e to the minus 4, 5 plus, this is 5, no? So I'm going to write in front of this, minus 5 e to the minus 4. Yeah, so this is 5. I'm going just to write it at the front. This is going to be equal to 90. And from here, k is 90 over that. And they say it's 99, but have we rounded to the nearest integer? Yeah, so let's going to check just in case. We have 90 divided by that, yeah? And I get 99.07 something. So 99.07 something, that to the nearest integer is 99. They might not tell you, find this integral first, and then just find the constant. And to find the constant, we will do the same. We will integrate between 0 and 4, and then make that equal to 90. That's what you really need to remember, yeah? Is this okay? So I think we have seen like a couple of questions that were GR12, where this function, instead of being complicated and integration by parts, it was just like a quadratic or something very, very simple. And still you do the same. You integrate your function between the limits, and then you make that equal to the area. Yeah. Now, estimate this probability using the normal distribution. So calculator, normal CD, limits, and then we find that value. Yeah. So normal CD, the lower is 10, the higher is No, the upper is 30, mu is 9.3, and no, sigma is 9.3, and the other one is 14.9. I get 0.6, so this is 0.6486, yeah, using the normal. Now, Xian's curve with equation 99x e to the minus x, and the answer to part C. How are we going to find the probability? How can that? So we have find this probability using this model, and now we have to find this probability using the other model. How am I going to find that probability? Anyone? Fraser.
Do you just integrate between those bounds?
Which bounds? Be careful.
Is it between 30 and 10?
Between 30 and 10?
No, I don't know.
We have between 10 and 30, but that's not the limits. Those are not the limits. What are my limits?
Is it 3 and 1?
Exactly. Yeah, be careful. That's why they highlight, I suppose, the tens of hours. So why are we now integrating again? Because in a normal distribution, remember, the area under the graph is the probability. So that is not for the whole curve, only it's for any bit that we want. So to find this probability, we are integrating, again, this function that we have the answer. So it's going to take very little, between 1 and 3, because in that function, we are using tens of hours. So we are integrating that probability that we need is the integral between 1 and 3 of 99x e to the minus x dx. And that's going to be my probability. Yeah, I know the integral of this. The integral of this. But I know the integral between 0 and n. That's not helpful, no? So I'm going to use this bit here before substituting, no? I imagine, and then multiply by 99. So I have minus x e to the minus x, minus x e to the minus x, and minus e to the minus x between 1 and 3. Yeah, be careful. We cannot use this result straight away because this is from 0 to a value, and we have between two values. So we substitute the 3, we substitute the 1, and then we should have it. Yeah, so 99. And then we have minus 3 e to the minus 3 minus e to the minus 3, and then minus, we substitute the 1, so plus 1 e to the minus 1 plus e to the minus 1. No, that's what I think we have. So please tell me if you get something different. And I imagine we are going to get something relatively similar to what we got before. I get 53 point something. Why I get 53 point something? Divided by 90, because that's the frequency. Sorry. We are not finding the, so when we integrate this, we get the frequency, we get the area under our polygon. So this is 53.12 something. We are finding the people that are between 1 and 3. So the probability is going to be that 53.1 something divided by 90, because we are finding the probability like in the very first thing. Yeah, divided by 90, this is 0.5903, which is not very far away from this one. So one is 0.64, one is 0.9559. Remember the first model, the normal distribution wasn't a great model because it's not symmetrical. So then the researcher decides to use Xian's curve to model the probability between A and B. State one limitation of Xiang's model. So Xiang's model is this one here. So not the one that is the normal, but this one. Any idea? What have you written here? You want me to show you what they say? They say patients might stay longer than 40 hours. Yeah. So we are stopping with that model. T is between 0 and 4, but we can have patients staying more than 40 hours in real life. Yeah. That is that one. This last bit is a bit strange. Is the question okay? It was super complicated. It's 2023. It's from Edexcel. And I think that question left a lot of people off wobbly. Any question? No? Okay. And then the last one is this moments question. You might have, so you're going to have moments. Most of the years you have one horizontal and then one more complex with angles, rods and something, but not always you have one of these ones. Yeah, so sometimes you just have the inclined one. Yeah, but it's important that we know well about these ones. So uniform plank has weight 100 newtons, length 4 meters. So I'm going to start drawing them weight in the midpoint. So 100, please don't multiply by G because it's already newtons. Plank rests horizontally in equilibrium to smooth supports A and D. We know the distances. Magnitude of the reaction at C is 75, so this one is 75. Modeling the plank as a rigid rod, find the magnitude of the reaction at D. So this is what we have. And we need this reaction at D. Yeah? Very quickly, we don't even need to take moments. Yeah? Forces pointing up equal to forces pointing down. So we have that 75 plus something is 100. That means this something is 25. So is 1 mark. It's just going to be for the answer. You don't even need to justify too much. Yeah, but it's resolving vertically. So the forces pointing up are going to be equal to the forces pointing down. I don't need to take moments. Yeah. Now the value of x, I will need to take moments. The value of x is this distance here. Yeah. So from here to C. What point we are going to take moments about? It doesn't matter a huge amount because now we know all the forces. So really it doesn't matter. Usually when we don't know a distance, the ideal is to get about one of the extremes of the distance and if possible, the extreme of the bar, the rod as well. But in this case, we are not going to be able to avoid the brackets, I think anyway. So it doesn't matter too much. So let's going to take moments about A. Moments about A. Who is going to help me, please? If not, who can help me to find moments about A? Svara, would you help me to find moments about A, please?
Yeah, so you can do 75x plus 25 brackets 0.5 plus x equals 100 times 2.
Exactly. Equals 100 times 2. Everyone? So this one is anti-clock, is 75 times x. This one is anti-clock, is 25 times 0.5 plus x. This one is clock, is 100, and this is half of the bar, so it's going to be 2 meters. And from here, very quickly, we are just going to get the value of x, yeah? So we get that x is 15/8 or 1.8. 1.8? That sounds, I don't know, close to x. Yeah, it could be. Yeah, meters. And we have taken moments about A. Please remember, in the test, in your exams, write what point you are taking moments about. It's going to make person marking lives easier, and you always want that. And this is 2. And now, stone block, which is modeled as a particle, is now placed at the end of the plank at B. and the Planck is on the point of tilting about B. So we have a block now here at B. Find the weight of the stone block. So we are going to write that this is W. You can write mg and find m, but because they are asking you the weight, don't forget to multiply it by g at the end. Yeah, if they ask you the weight, they are not asking you the mass. We need the weight. So we will find the mass and multiply by g, or just write W. And it's on the point of tilting. So who can tell me what is that doing? Daniel.
Is it where one of the reaction forces goes to 0 because it's tilted to the side?
So which one is going to 0?
C.
C, exactly. If it's tilting to that side, this is because this is about to lift. And if it's about to lift, this reaction has disappeared. So we are at the point that the reaction has disappeared, but it still hasn't started moving. Yeah, that's what it means in the about to tilt. Yeah, so this normal reaction disappears because there is almost no contact, but it hasn't moved yet. And now what we are going to do is take moments. Where can we take moments about? We need W, so it doesn't make much sense to take moments about B. This one is the same or it has changed? So RC disappears. RD is the same or is different? Has changed. Svara, why it has it changed?
Look, I don't actually know the reason. I just know that it has.
If I remove one force, the other forces have, if it's in equilibrium, they will have to adjust. So if this support is not supporting force, then this one is supporting more. Yeah. And I have even added one force here. So this force is not going to be 25. And I cannot easily find it because I don't know this one. So this one now will be 100 plus W, but I don't know W. So why complicate my life? I'm just going to take moments about D. Yeah, and then that force won't be in my equation. Yes. So if we take moments about D, what do we have, Amelia?
We have the. Wait, I'm really confused on this one. Why do we not have a reaction force at C anymore?
Because it's on the point of tilting. So when something is on the point of tilting, that means, imagine this is just on top of that without the screws or anything, and you have now a weight here. This is on the point of doing this, yeah, lifting, but it hasn't lifted yet. When that happens, the farthest weight from the farthest support from the weight has no force anymore. It's like it's about to move, so it's just on the air, so no force, but it's not moving yet. So this disappears always. Every time they say it's on the point of tilting or on the point of rotating, that's what it means.
Okay, yeah.
So I don't have this force anymore, so I'm going to take moments about this one. Do we know all the distances? This is 4. We know this distance. We know this distance, so we will have to work on it. So what is my clockwise moment? Is going to be W multiplied by this distance that we have to think a tiny bit. No, this distance is 4 minus the 1 point something that we found minus 0.5. Yeah, so I'm going to work that distance as 4 minus the 1.8 something minus the 0.5. So that distance, this distance here, is 1.625. So that's what I'm using in that. So it's W, this is still W, W multiplied by 1.625 is going to be equal to this one. This one is 100 multiplied by this, no, I'm taking moments about this one. So this distance is what? What is this distance? This is not, this is in the midpoint, but this is not in the midpoint. So this distance is this distance here, minus 2, No, I hope I'm doing it correctly. So this distance up to here is 2.375, and then I remove what, 2, no? So 0.375, I hope I'm doing it correctly. So 100 times 0.375, yeah? So W is 23.07. Let me check. 23, okay, 23, yeah, okay. Yeah, so that's the weight. I have to multiply by G if I find the weight. If you decided to find the mass, don't forget to multiply by G. And now, explain the limitation of modeling the stone block as a particle and then the plank as a rigid rod. Stone block as a particle. What would you say to this one? Limitation. So what is wrong? What I'm missing here if I model the block as a particle? You can tell me something. The block will have dimensions, yeah? And I'm just considering that the whole block is just in one point. While in real life, the block will be a bit thicker and then my force will be kind of spread through something, yeah? So I'm just considering the whole block in one point. And the plank as a rigid rod. What is the limitation? And considering that this is not going to bend at all, yeah, but in real life, if the things are heavy, probably will bend a little bit. So let me show you what they say. Modeling the stone as a particle assumes that the weight of the stone blocks acts exactly at B. Yeah, so they are ignoring the dimensions. And then this one is modeling the plank as a rigid rod assumes that the plank remains in a straight line and does not bend. That's what we are assuming. Yeah. For those who have Edexcel, you have a really nice table that you maybe don't remember in your textbooks. In chapter 8, in the year 12 textbook, that says all the things that you are assuming when you are modeling something as a string that is light and inextensible, a pulley that is smooth, a rod, a particle, yeah, all those things that comes in the table. Yeah, and I think it's a good thing. Okay. That's it. I think the worst was the statistics, no? I think. Okay, then I hope to see you at 3:30. I give you a few minutes, half an hour. See you later.
Thank you.
Bye.
Thank you.
Bye.
Thank you.